All right, so we're going to go in trigonometric functions and properties. So starting the trig part of this class when it comes to it. Okay, so we're going to go straight to the second part. When it comes to the main basic concepts of what the trig functions are all about. So essentially what this happens, right, is given a circle with a center, and it's usually going to be the origin or self, right, to help us. So the very first parts. The question when it comes to the trig functions is if I give it a point on the circle, let's say P, with its x and y, we got to figure out what is the degree it makes, right, when it comes to that portion. Or so, what is the length from here to here based on this angle itself. And the x and y corresponds to, the x being here and the y being there respectively, but it all corresponds to the angle itself, right? We want to figure out what that angle is to give you the exact length there. And that's where this trig functions come into play. It's a brief summary, of what it's all about there. So from that, we have the most, the trig functions itself, right? The sine is sine theta is equal to the y, cosine theta is equal to the x coordinate. So given a point, sine theta is equal to the y component, cosine is equal to the x component, and then we go off to the other ones, right? Tangent is all the next six are the combinations of each one. So tangent is the y over x, cotangent is the opposite, x over y, secant theta is 1 over x, and cosecant is 1 over y, respectively, right? And all corresponds to basically knowing those two itself, right? So when it comes to, in general, broad sets, right? So given a circle now, which we'll talk about circles more in depth in the later sections, is, again, given a point here, x and y, where we have, let's say, that portion, that's going to be a radius. So given, so if I give this out here, x and y, so essentially what we'll care about is this nice rectangle. So this is going to be r, this is the x coordinate, and this is the y coordinate. And that's how we're going to figure out this kind of stuff. Now, obviously, right, the most important thing is when it comes to the right triangle is Pythagorean's theorem, which is going to be using a lot in the next couple of sections when it comes to the trig functions, right? So a quick review of the Pythagorean theorem is a squared plus b squared is equal, let's say, r squared, since we're doing r itself. Okay, so we're going to be using that to figure out our sines and cosine functions itself. Okay, in the general broad spec. Okay. Okay. All right. So in that case, let's try. Because of that, now we have our new trig functions with respect to the right triangle itself. So sine theta is actually now equal to y over r. Cosine is x over r, and again, vice versa for the tangent, cotangent, cosecant, and so forth. Okay. So what we want to do now is, well, given these properties, how do we find these using now any point on a circle, right? The thing is, when it comes to these portions up here, we're doing the actual unit circle where the radius is 1. So if you notice, right, y over 1 is just y, x over 1 is just x, right? So nothing really changes there. But because the radius now changes, right, we can have like a bigger circle, a smaller circle. We want to figure out what happens when it comes to those kind of portions. Okay? So let's try this out so we can see what's going on. Okay, so find the 6 trig functions of the angle theta if each point on the terminal side is standard position. Okay, and we'll talk about what this terminal side and standard position means right now. Okay, so the best thing you want to do is actually make a circle. Okay, just like that, and you kind of want to, figure out where this point is going to be. So here's -1 and -2 is down here. So, let's say it's roughly here. Okay. Now if we make our triangle like that, and remember this is the x coordinate, so it'll be -1, and the y coordinate is going to be -2, right, respectively to our portion here. Right. The radius is always going to be from the origin to the point itself, so that's r. Okay. Now what this means by the terminal angle. Okay. So terminal angle in the standard position means you're starting here always and just rotating that way. So theta is going to be right here. That's what the standard position corresponds to. So this is the theta we're looking for. Now in this class, unless otherwise told to you, theta is always going to be in standard terminal position. I mean, it's always going to be right next to the right angle here, okay, to help you guys out. It just makes it easier for, the rest of us, okay? Now what this says is, well, given this triangle now, go ahead and now find the trig functions associated with that. So you notice the first thing we have to do is actually find r, right? So Pythagorean theorems, we have -1 squared plus -2 squared is equal to r squared. So this would be 1 plus 4 is equal to r squared. This is 5 equal to r squared. So r is equal to radical 5, okay, when it comes to it. So now using these trig functions, all we're going to do is plug in x, y, and r respectively. So for instance, sine of theta is equal to the y component over r. So the y component in this case is negative 2, so being negative 2 over radical 5. And we just keep going. So cosine theta is equal to the x component over r. So the x component is negative 1, so negative 1 over radical 5. And we finish it off. So I'll just quickly do the rest of them. So tangent theta is equal to the y component, negative 2 over the x component. Right? Or simplify just positive 2. Cotangent is just the opposite. Secant theta is now r over, so notice this is the opposite of the cosine, so it's r over x, so radical 5 over negative 1, and then finally cosecant theta is just radical 5 over negative 2. And there we go. There's your trig 6 functions based on the circle. Okay. So why don't you guys try B and C? Well, almost identically the same process we did here. So I'll just quickly pause it and go for it. 3, 2, 1, pause. Okay, so hopefully you guys tried them out. Let's see what we have here. So positive 4 is over here, negative 3 is down here, so here's your point. Okay, so right, it's 4, so that's your x, and you're going down, negative 3 as your y, and now we're going to find r to figure out the rest of them, right? So here we're going to have 9 plus 16 is equal to r squared, so this should give you 25. So r is going to equal 5. Okay. And now we'll just go down the trig functions, right? So sine theta is y over r. So minus 3 over 5. Cosine is x over r, so 4 over 5. Tangent theta is y over x, so negative 3 over 4. Cotangent is the opposite, 4 over negative 3. Secant is 5 over 4, and then finally cosecant is 5 over negative 3. Okay. Right, and the last one, 6 comma 8. Positive 6, positive 8, so it's going to be over here. And again, right, it doesn't have to be perfect. All this is just showing you, where the triangle is going to be, right? It doesn't have to be perfect, it has to be up across 6 and across 8. It just gives you an idea, visualization where the, triangle is going to be. That's all this really is, okay? So it doesn't have to be perfect. So r squared is going to be 36 plus 64. So r is going to be, I think, 100. This adds up 100, so take the square root, should give you 10, right? Right, so same process, right, once you get there. So I'll just quickly go down the list. And there we go. Okay. All right, and that is the first portion of trig functions and properties. That's it for this section. Pretty short section when it comes to it.